So that's number 2. Let's look at number 3 here. It says predict the product for the following reaction sequence. So I have 3 of these guys here, right? So the first one here, so I have a carbonyl group here, and I'm reacting it with this group here. And I have H2so4. And then the second one here is, I guess this is a 3-part question. And this is, again, I have a cyclohexane here, double bond here. I add H3O plus in heat. And then finally, if I scroll down here, I have here, this is a cyclohexane with cyclohexanal here. Not hexanal, but just an aldehyd here. With this is CH3COOH. So this would be a bond OH here. Yes. Let me just double check here. Yes, this is correct. Okay, so take a moment to think about this question here. So I have, this is again, I'm predicting the product for the following sequence, right? So I have, again, I have a ketone here, and I'm reacting it with this cyclic cyclic group, present this acid to form something. And then I have this as a kind of an amine group here with a double bond here. I'm adding acid to form something as well. And then finally this aldehyde with this carboxylic acid. So let's look at this first one here. I'm going to see what they wrote here to see if they have the solution correct. So they wrote here that the first one here, they have the electrons from nitrogen here going towards this oxygen. And this would break the double bond to form this guy here. Okay, so and then they're doing a acid workup to produce this compound here. So let me just write this out and let me just verify it. So let's see. So they're saying the lone pair from nitrogen here is going to attack, and then this is partial negative and this here is partial positive. It's going to attack this here and it's going to kick out this oxygen. So when I do that, I would get something like this. I would get OH here, and then it would be attached to this N, and then you can draw the O here. You get this group here. And then in the presence of acid, so H3O plus, this would be able to kind of, I have again partial negative charge here and I have a partial positive here. So what it's going to do, it's going to add a negative here towards the OH2. So again, I would get something like OH2 here. So we get H2O. So we have a positive charge here, and then I would have a nitrogen like so, and then I'm gonna maybe erase this and give it this is blue, I'll give it a positive charge here, and then let me erase this one to give it a positive charge here. And what it's going to do is, again, this nitrogen is going to collapse, this lone pair is going to attack, collapse on this double bond here. This is going to kick, OH2 is a great leaving group, so it's going to kick this out and then form this structure here. It's going to form something like this. It's going to form this double bond between N here. And then I have this. Is it like that? Yes, like that here. And this would have a positive charge here, right? And then finally, it's going to eliminate. Again, this H here is going to simply, again, you can think of it as an elimination reaction, or you can move the double bond basically it's going to resonance stabilize, right? And how it does that is this double bond is going to basically be brought down here. So this here is going to kind of bring this up. So therefore, it's going to create a double bond within the cyclohexane group. So you get something like this. This would bond N here, and this is finally bond O here. So let me just erase this. bond O. And this here would be our product here. And they got this one correct, and this one here is correct, right? So basically what we did here was there was a, we did a nucleophilic kind of attack here on this double bond. It's going to form this kind of intermediate here. There should not be a partial negative here, sorry. The acid workup makes the hydroxyl group a great leaving group for the nitrogen to kind of collapse on itself to form this double bond with the on the nitrogen, and then finally it's going to resonance stabilize to form something like this. So this here is a correct solution here. That's great. Number 1 is correct. So solution is correct. Let's look at number 2 here. 2 is kind of the same thing, right? So again, I have this kind of acid group here. What it's going to do, again, I have this, what they wrote here is that the nitrogen, the lone pairs of nitrogen are going to, again, attack here, or not attack, but it's going to shift and resonance stabilize here, and it's going to eliminate a hydrogen. So it's basically, this here is going to get kicked out, and basically it's doing the opposite of what we were doing here, right? So it's going to create a double bond with the nitrogen here. So this is going to go out. So instead of double bond being here, it's going to be back up top, like we said. So, like our thing before. This would now have a positive charge on nitrogen because I'm making 4 bonds. And then what it's going to do is I have my acid here. It's going to attack basically this. It's going to basically do a kind of like a I would say maybe an SN2. Or probably an SN1 reaction here, actually. And basically, it's going to kind of attack the double bond. Again, I have a negative charge here. It's basically going to make a hydroxyl group. So it's going to, the OH minus on the acid is going to kind of attack the double bond here. So it's going to break up the double bond. So you're going to form an OH here, and then form your nitrogen with your the little wings here. So this here, and with it, I still have a H here. So this is still partial, still positive here, and then what we can do now is that this here makes a very, very good leaving room. I can basically again do another acid workup, and basically get rid of this. Get rid of these guys here. So again, this lone pair from oxygen here can collapse here. This entire thing will get removed. So this here will form, again, this is now my double bond O, and then it's going to bond H here. So this is a positive charge. Let me just erase this. This is a positive charge here. And then finally, another acid workup would make it so that this the H here would just leave, right? If I were to H3O plus here, you can donate one of these. Take this hydrogen away, and we get a ketone here. So this is basically the exact opposite of what the first question here, which is totally fine, right? Again, what we're doing is we're looking at this guy here. Again, this negative charge is going to we're doing a resonance stabilization. So we're bringing the double bond back up here, making a great leaving group for the hydroxyl group to collapse itself on, and then we would form our double bond carbonyl group here. Finally, number 3 here, we have these are products here. So this guy was what we care about here, and we form it basically breaks these 2 guys up into a ketone, and then basically whatever the diamine group that we have here as well. And then finally we have this aldehyde group and a carboxylic acid group. Again, very, very easy solution here. What we're doing is, again, the negative charge on the oxygen here is going to come and attack this guy here. This one here is a partial. This is partial positive. This guy here was partial and negative, and what it's going to do, it's going to kick this carbonyl carbonyl group out here, and then let me just draw the arrow down so we have a bit more space here, and then when we get something like this, we get kind of this intermediate here. So we have this here is bond O, this here would be now bond H, and this here would be now be bond O. Bond O. And then bond O, bond. and then bond, basically something like that. This would give this guy here, this here would get a negative charge. Whoops, I want to do that in red. This here gives it a negative charge here. And what it's going to do is going to collapse on itself. It's going to collapse on itself and kick out this hydrogen here. So I would get a, it's basically just going to break these two guys into two parts, right? It's going to break this entire thing into a carboxylic acid plus a your O minus here, right? So your O minus, like so. CH3, yep. So this here I would get something like this. And finally, what this student asked said, I don't know if I get a proton group here. Do I have acid? Oh, I do have heat. I do have. No, I don't have acid actually. Let me look back up here. No, I don't have acid here in this case. But I'm assuming if I have like some sort of acidic, and it's done in a solvent, I would get. I can acid work. I can do acid work up here and get something like this. Yeah, like that. So these two would be my kind of products here. So the solution here is correct. I like how they showed the mechanisms and the arrows here. So this here is a great solution here. Great solution analysis. So basically, is again this question is asking resonance stabilization and basically nucleophilic attacks, making good leaving groups so that you form a different compound here. So the solution here is correct.